Hi everyone. So today I'm going to be talking about reviewing and securing React applications. Just a quick raise of hands, who's heard of React? Right, okay, presumably everyone. It's a framework by Facebook. And just another quick show of hands, who's familiar with JavaScript and specifically React? Or who uses it on a sort of regular basis? And just another quick one, who's a Facebook engineer working on React? Okay, okay. I had a feeling there'd be some, at least. So just before we go in, just a quick introduction about myself. I work as a security consultant, specializing in software security at Synopsys Software Integrity Group. My main interests are static analysis and code review. I also do a bit of developer training time to time. And in the past, I used to work as a software engineer, then I went to security engineering, and then eventually ended up becoming a consultant. So what this talk is about today is, before we dig into any sort of security issues in the use of React, I want to just give a quick introduction to React, because there's some people who might not be familiar with it. After that, we're going to talk about securing your React application, and then we'll speak about remediation or how to take care of common patterns that could go wrong. So what is React? So React is a front-end library for building user interfaces. I think on their website they mention it's a library for ambitious user interfaces. It's something that Facebook uses. It's built by Facebook. It's components-based. And one differentiator, I guess, for people who might not be familiar with JavaScript frameworks is that if you might be familiar with something like Angular, React only really does the sort of the rendering, or specifically the view side. Whereas in Angular you can do things like routing. It has a thing called virtual DOM, and that's typically in a nutshell, it's essentially there for faster rendering. There's demos you can see on GitHub where you try and make loads of state changes on the DOM, the native DOM, the browser implemented DOM, and then the virtual DOM. You can see the performance ways, and it has one-way binding in components where essentially data flow goes through, passes down from one component to another component. Compared to other frameworks where you can do different things. So why do developers use React? Well, one of the main things really that stands out for me, and something I see in a lot of code reviews, is that a lot of applications are built using Create React App, which is a scaffolding tool for essentially quickly generating your React application. So a lot of large enterprise companies use it. It's got a really high rate of adoption at the moment, and compared to, say, Angular, it's got a much smaller attack surface, and you can think about it in terms of attack surface reduction. It's actually a really good thing to adopt. So I'm going to just dig right into the code. What we have here is a very basic React component, and it has a very basic state called hello world. And then it has a render function up here, which has an input, which we can see it's been rendered here, and then it essentially prints out what's in the state. And you can see, you can say hi OWASP, and that's just to show a very basic component to see what you can sort of do with React. This presentation entirely is actually built in React as well. So let's talk about some security properties. So out of the box, the framework comes with output encoding. So in general, if you were to try and attack the application the sort of the traditional way, as a penetration tester might do, you'll see actually by default, I haven't had to do any sort of specific thing to say actually this is a HTML tag, or I have to do any sort of HTML encoding. It sort of comes out of the box, and that's one really interesting thing about the framework, and it provides a lot of security. But what if, let's say, in this example, I wanted my users to be able to say put bold tags? Well, in that scenario, you would end up doing something like this, which we see in the next slide. So in this slide, we have the state is actually a HTML tag. And the way the difference between this one and the last component is that in this scenario, the application is being the text is being rendered via this prop type here called dangerously set in a HTML. And what that essentially does, the name is kind of obvious. It dangerously sets in a HTML. You can inject script tags into it, and we can kind of see this, right? I can definitely do like hello. Alternatively, I can also do a traditional cross-site scripting attack. And there we go. We have a the pop-up box everyone aims for. So I know a lot of you might be thinking, who would do that, right? The one thing that really sort of I've noticed in the last couple of years is that, last year or so, is that a lot of frameworks are now having much better naming conventions. So compared to, say, who's familiar with jQuery, right? jQuery had functions like .append, .prepend, or .html, where it was actually the underlying part of the function was actually manipulating the inner HTML rather than the text content. So the function, if you was to use it on a dangerous user-supplied input, it would actually lead to XSS bugs. Whereas now you can kind of see, hey, look, this is kind of dangerous. Be careful, don't use it. It's the same thing with Angular, where it has methods like bypass security trust. And the naming convention here is very explicit to let the developer really know what exactly the method's doing or what it could be doing. So you might think, actually, who would do that, right? I mean, why would you render user-supplied content in a way that's sort of rendered dangerously? So who's heard of use signal, use Tor before the phrase? Okay, I see a few hands going up. So right, who would do that? So this was actually a bug in the Signal desktop application where you could essentially render malicious messages, and so this actually led to a code execution bug because it was built using Electron, which is a way to render web applications on the desktop. And you can see, actually, the patch was to basically get rid of dangerous set in HTML. What's really interesting about this bug is that someone originally found another bug, posted a video of that bug on Twitter, and then people tried to figure out what the bug was, downloaded the code base, grabbed for dangerous set in HTML, and found another bug. So that's kind of funny. So yeah, I mean, that's the main thing you really have to watch out for in React is this one sort of override where you dangerously set in HTML, and it can lead to a lot of cross-site scripting issues. If you absolutely must do it, you could use iframe sandboxing. So sort of the way you might have ever noticed domains like Google user content or FB user content or something like that, where essentially you would put it on a completely separate host and then embed it via an iframe. You can also use DOM Purify, which is essentially a way to, if you really must do it, you can use DOM Purify to essentially sanitize your input. So in this scenario, we can see we have the same sort of component, but in this scenario, we're doing this DOM Purify sanitize, but also using dangerous set in a HTML. And what DOM Purify is essentially is a library by a consultancy firm called Q53, and what it does is strips out dangerous tags in input. So in this scenario, I can do things like hello, or in fact, let's make it italic. I can add a italic tag, but I can't quite do the traditional XSS attack, right? And we can see right here, if I was to inspect the element, I'm sorry, I don't know if this is big enough. We can see, right, the on-error attribute has been stripped out. And this is surprisingly common bug I see in a lot of code reviews. The second I see a React application, this is the first thing I grab for. And then I check for, like, hey, look, is there any user-supplied input being passed into it? So, as a developer, you might think, okay, well, this is sort of, I've got output encoding out of the box. I don't want to use dangerous set in a HTML. But there's other things you kind of have to watch out for in the framework as well. And one of these things is essentially um, this way where you can inject stuff into attributes, specifically href links. So in here on the left, I have a component that essentially renders, maps over the array in the state, which is set up here. And if I add stuff, so let's say I add the following link, Google, right? It will render it, and if I was to click it, it would open Google. I'm not connected to the Wi-Fi, so it won't quite open it. So can anybody think of like a way to exploit this? Okay, so one of the ways you would take a look is you could you could add a data URI. And if I was to click it, again, you would get a cross-site scripting bug. So even though the framework has things like output encoding, it doesn't quite capture every specific edge case. And this is one of the main edge cases as well. You can kind of use to sort of trigger a cross-site scripting bug in your application. So one way to avoid this is to essentially do protocol validation. So we can see here in this component, URL issue fixed. Right prior to adding the link, I essentially pass the URL up here, and then I check the protocol, and that if it's not HTTPS, then I ignore it. I've seen this go wrong quite often as well. So like a developer might know, hey, look, I need to be careful with the links I'm injecting into the framework. And then they'll end up using regex, which is not quite the best way to parse URLs. This is kind of a newer API. It doesn't quite have support in slightly some of the older browsers, so you would have to polyfill it. But yeah, this is probably the better way to do it instead of regex. And we can see it right here. We can say https.google.com is allowed. Not so much JavaScript alert 0. Right. If I was to enter it, it just triggers the function and then returns it, because that's not one of the whitelisted solutions. Everyone with me so far? Okay. So up next, I want to just talk about server-side rendering. So server-side rendering is really not too common, but it's another one of those edge cases where you have to sort of watch out for things. But before I go into that, I just wanted to explain what server-side rendering is. So essentially, as the name suggests, you can render your entire or parts of your application, your React application on the server, and then serve up to the client. And so it can lead to better response times and better user experience because you've got a faster application. It also allows for a thing called code splitting, where you send chunks of the code to the client. It's useful for like search engine optimization, but it can lead to an increase in complexity and adds a little bit to the attack surface. So up until recently, this was actually what the Redux application. So who's familiar with Redux? Probably. Okay, so Redux is a state management framework, which is, you see a lot of Redux being used in React applications. And up until recently, this was sort of what was in the docs, where if you wanted to send the preloaded state, you would do it like this. Now, of course, this can lead to cross-site scripting issues again, and this is really the only scenario where you would see a reflected cross-site scripting bug in React applications. And what we have here is essentially we have this method called, or function called render full page. It takes in HTML and preloaded state, and then it goes ahead and just renders, does JSON stringify on the preloaded state, which is supplied by the user. And of course, you can break out of it. You can break out of the script tags and then trigger an exercise that way. They did actually update after a big Medium post, they did actually update their documentation, and this is what they recommend. And it sounds right, but essentially any output you would put into the JavaScript state has to be escaped in the correct context. The other thing you also want to do is keep your framework up to date. So a few weeks ago, or a few days ago even, the React DOM server API had a quick update where essentially, if you were to pass in a prop name, or rather the key of the prop, you could potentially trigger an XSS when you were rendering it. Likewise, there was a previous issue with create element, which was found on the HackerOne application, where essentially you could create a dangerous element if you were passing in user input to create element. But now again, this has also been fixed. So that's another thing you kind of have to watch out for when you're using React for your applications. Up ahead, we have third-party components. So you'll see a lot of Node.js applications, or rather JavaScript applications. There's this common thing where, even something I do, where like, hey, look, I want to build something. I want to add, like, let's say, some sort of component to my application. I would just go search GitHub and see something with like lots of stars, and I want to show like images in a slider or something. I can go ahead and download that sliding component. And sort of use it in my application. And it is very, very tempting to use external components, and absolutely you should use it. But just be worried that GitHub stars don't equal to secure. More often than not, I've seen, especially the more complex components, might be calling, somewhere hidden in there might be some sort of DOM XSS where it was, or some sort of dangerous thing in React. So that is definitely something you have to watch out for. And I thought it would be hilarious to reference this one, seeing as client-side CSRF, seeing as we're talking about React at Facebook. So this was actually a bug found, I think, as Jack mentioned earlier in his presentation, a bug found in the actual bug bounty. And essentially, it boils down to two things, right? Lack of path normalization and having URLs that conduct sensitive operation. So I kind of actually like recreated this in a quick little code snippet. So what's happening here is essentially, as Jack explained, right before your component mounts, you essentially extract the token from the client side, and then you get some sort of user-supplied input from the URL, and then you sort of do string concatenation right in the URL in the fetch API and pass in the options. What happens here is that if you were to go to the endpoint without the token, it would give some sort of error. But because you're leveraging this internal method inside the application, which passes in the token, which is stored on the client, this action would go through. The other thing you can also do, of course, for the bug to work is essentially client-side path traversal. So again, let's talk about remediation. So if you were to rewrite that, you kind of have to, again, leverage whitelisting on user-supplied input. So in that scenario, you would double-check, hey, look, my user-supplied input coming from window location hash. Is it actually what I'm expecting? Is it an integer that I'm expecting, or is it one of the strings in this array that I'm expecting? And of course, you can normalize the URLs prior to making the request, especially authentication requests. And so that sort of covers most of the sort of common issues you would come across in React applications. So in terms of the threat model, you have your generic DOM-based XSS along with some specific React-specific issues. So let's talk about proactive measures, right? Like, what can I do as a developer to really leverage the sort of latest web application security features, right? So Google did this really great research on using CSP properly, where essentially they scanned a lot of pretty much a lot of CSPs on the web, like hundreds of millions or maybe billions, and they essentially found like common issues with them. And this is a really good paper that I've linked. But essentially, in a nutshell, you should use content security policy with strict dynamic. You shouldn't use things like the unsafe inline or unsafe eval directive. Webpack actually has a really good, easy integration. Webpack, for those that aren't aware, is essentially a build tool for building your JSX and then transpiling it to ES5 or ES6, whatever your target is. And it's really easy to set up. All you have to do is add it as a new plugin. It's a really easy package to use. It's one of those quick security wins you can get if you are working on a React application. So in conclusion, you have to be very careful when you're using dangerous set in a HTML. It's as the name implies, it's extremely dangerous. Maybe they should change it to extra dangerous. I don't know. That it could have prevented the signal issue. Leverage URL protocol whitelisting if you are rendering these hrefs into your application. Double check any third-party components. Just because it has a lot of stars, it does not mean it's secure, so to say. Just because it's popular, and it's really easy. All you have to do is kind of just go in and just take a look, just to make sure it's not doing something silly. Make generous use of npm audit for dependencies. So npm audit is a new sort of command built into npm recently, I think in the last couple of months. And what it lets you do is it lets you audit all of your packages for any known issues. So if you are using a vulnerable package, which you almost certainly are if you've never audited your npm packages, this is a really good way to do it. And finally, leverage linting to detect the use of dangerous functions. So when you scaffold an application with create React app, it will actually by default let you know if you are using things like dangerous set in a HTML or anything like that. And it will also tell you, for example, if you're creating a href link without rel, no opener, and stuff like that, where essentially you could leak a referrer. So ESLint is really cool. I use it. It comes with tools for React. And finally, the other thing as well I want to show for people who essentially for penetration testers who have been looking at React applications but don't quite know how to start. One way I think a lot of penetration testers I speak with might not know is essentially this Chrome extension called React DevTools. And what it lets you do is essentially review React applications the way the components are. So for example, if I was to take a look at the standard DOM, I can see like, okay, I have loads of diff classes. I don't really know what it's doing, especially if your code is minified. You can't. I mean, for the client-side CSRF bug actually that was reported. If you read the original write-up, the guy actually looked through the minified source code, which is actually really impressive, I think. But I think there's a slightly easier way. You can just, if you are working on a React application, you can kind of just install the React DevTools and sort of take a look at the components much easier. And that kind of covers it all, really. Thank you. Any questions?
Thank you. So we have one question online. So one asks about DOM Purify. Does that mean it's using blacklisting as opposed to whitelisting?
Technically, well, I'm not sure how exactly it's implemented, but I believe in terms of, I'm not sure if I can answer that, but I think it uses some whitelisting in the background and it strips out tags. And you know what? Actually, that's a really good point about using whitelisting over blacklisting, because even if you do use DOM Purify, the reason I say you should use a different origin with iframe sandboxing is because even if you do use DOM Purify with dangerous set in HTML, your application, the final rendered output will still include things like, for example, if you wanted to put a data attribute, and they will still include that data attribute. And now that can actually lead to a gadget on the DOM side, because if that data attribute is then passed into a dangerous function, you can still get a cross-site scripting bug.
Thank you.
Excellent.
There was one more asking about CSP.
Yep.
But would that actually help, or is it too complex for such a thing?
So if, let's say, for example, I had a scenario where I had script source on my CSP and I had a whitelist of allowed origins, right? Now, of course, not in every case, but I think it provides some mitigation, especially, let's take, for example, the reflected access. Yeah.
Thank you.
Can I check with the audience?
Does anyone else have any questions?
No? Okay. Oh, one more. Yeah, one question here.
You got any ideas? What's the best sort of way to build some of this into an AppSec pipeline?
So that's a really good question, and that's something I've done before. So of course, like things like if you might be doing things like static analysis, right? And you might be using things like, am I allowed to mention the product names? I don't know. Okay,
Well,
right.
they say they're commercial products.
Commercial products out there. and a lot of them won't actually support JSX. They don't have the parsers for it. That's something I've done in the past as well. Like you can just go out and use your own parser and write a rule on top of the AST, but that doesn't quite do much. And in fact, that's something that ESLint will do for you. So yes, what you can do is you can just enforce ESLint, and you could potentially make the build fail. If, for example, if you use the dangerously sign HTML rule in React, you can make the build fail and it won't go to production. But I think that probably might annoy your developers. And of course, the developers can also always just override the ESLint rules. But in terms of static analysis, I don't know if...
That's quite a good pattern, though, is that if they want to use something that Linda doesn't like, they should override it. If they don't know how to override it, then they should...
What's really interesting is that if I do use ESLint on any code that I'm using, there's an option where you can tell it to ignore comments. So you can bypass their override.
Yeah, I think what we're missing is an OWASP project, right?
Yeah.
CI/CD integration and React. Okay, any more questions, guys? No? Okay, let's thank Amanvir for a great talk.
Thank you.